Number 53. Perform the following calculations involving concentrations of iodate ions. And then we have letter A. So the iodate ion concentration of a saturated solution of LaIO3 was found to be 3.1 times 10 to the negative third moles per liter. Find the KSP. Okie dokie. So we need to find a KSP value, right? That always comes from a balanced equation, right? And it seems like we have a saturated solution of LaIO3. So this is the solid that's going to dissociate into its ions. So we'll start there. LaIO3, that's the solid. This gets dissociated into its two ions, right? And the two ions are going to be La, right, with the IO3. IO3 is the polyatomic iodate. So we have La plus IO3. Now, we can use the subscripts to find out what the charges were, right? There was 1 La and 3 iodates. This 1 crisscrosses up, telling me that the iodate was a -1 charge, and the 3 crisscrosses up, telling me that the La is +3. These have both charges, so they're aqueous. And now I just need to make sure that I have a balanced equation, but I see that I have 3 iodate ions, so I know that I have to put a 3 in front of the IO3 here. Okay, and now we're good. Now, they did say that the iodate ion is IO3. That's the IO3 minus, so this ion over here. The concentration was found to be 3.1 times 10 to the negative third moles per liter. Remember, moles per liter is just molarity. So this value is 3.1 times 10 to the negative third. Okay. Now, we want to find the KSP value, right? So if we want to find out what that KSP value is, I should know the concentrations for both of these. I can't have an X value for La3+ and then try to find the KSP. You're only allowed to have one, unknown. And in this case, the unknown is the KSP. That's going to be the X. All right. Well, that means somehow I need to find out what the La3+ concentration is. But that's where we look at our mole ratios, right? There was 1 La for every 3 IO3s. So it's a 1 to 3 relationship. So if I want to find out what the concentration is here from 3.1 times 10 to the negative third molarity, I could just use a mole relationship, right? So if I want to just write it out, 3.1 times 10 to the negative third, right? That's for the IO3. And if you want to put down molarity, that's fine with me, right? Molarity of IO3 times by the ratio. IO3 goes on the bottom, and your La3+ goes on the top. Since there's 3 iodates for every 1 La, it looks like all we have to do is just take that value and divide it by 3. It kind of makes sense. The iodate ion is always going to be 3 times the amount of your La. So we're just going to just take that value and divide by 3. Okie dokie. So let's go for it. Calculate time. 3.1 times 10 to the negative third divided by 3. And I get 1.03 times 10 to the negative third molarity. Now we have both values. Remember, we don't care about this one because solids don't get included in KSP. Now let's just plug it in. Remember, the general formula for KSP is this right here, right? It's just equal to the products raised to their coefficients. So in our case, the KSP is going to be equal to, there's 2 of them, and it's going to be the La3+ times by the IO3 minus, but since I have 3 of these, I have to raise my iodate to the 3rd power. Now let's just plug in the values, right? KSP, which is what we're trying to solve for, equals, we have 1.03 times 10 to the negative third times 3.1 times 10 to the negative third, and that's cubed. I'm going to do this all in one shot in my calculator. Let's see if your answer is the same as mine. And then we are done for this problem. So let's see. 3.1 times 10 to the negative third, cube that, and then times up by 1.03 times 10 to the negative third. And 2 sig figs. So 3.1 times 10 to the negative 11th. And that is your final answer. KSBs do not have units, so whatever number you get, that's the answer. Okie dokie. I really hope this helped. I think there's one more part in this question, so hang tight for part B. If you guys are on the playlist, which I highly recommend you are, I will see you in about 5 seconds. All right? In the meantime, if you wouldn't mind, please hit the subscribe button. Thank you so much, and I will see you in a little bit. Bye-bye.